All right, so let's look at the next. We're going to look at secant. So secant, remember, can be defined to be 1 over cosine. And that's because it's the radius divided by x. So already we know we're going to have some domain issues, right? Anytime that denominator is equal to 0, that's where we're going to have an issue with domain. And if you think about that unit circle and where that's happening, cosine is equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So anytime we have those odd integer multiples of pi over 2. So for domain, it's going to be everything except 2k plus 1 pi over 2. And I'm going to rewrite this as theta instead of x. That way it matches my theta right there. So the range for this one's going to be kind of funny. It's going to be all y values less than or equal to -1 union with y values greater than or equal to 1. So period's going to be 2 pi, vertical asymptotes, odd integer multiples of pi over 2. This is going to have some even symmetry because it's defined in terms of cosine, and we know cosine is an even function. So let's look at what this graph is going to look like. So I'm going to think about this in terms of 1 over cosine of theta since we're dealing with the unit circle. So we're going to look at here. We're looking at negative pi over 3. So if I look at negative pi over 3, it's going to be here. So I got negative square root of 3 over 2 divided by 1/2. Negative square root of 3 over 2 divided by 1/2. All right, hold on a minute. I'm thinking about the wrong trig function here. Let's go back to secant. Secant's 1 over cosine. Cosine is the x value. So I'm at negative pi over 2. So I'm going to have 1 divided by 1/2. There we go. 1 divided by 1/2. And that's going to be equal to 2. And I'm going to look at 0. So at 0, I'm going to have 1 divided by 1, which is 1. At pi over 3, which is here, I'm going to have 1 divided by 1/2. 1 divided by 1/2 again is a 2. And then at 2 pi over 3, I'm going to have 1 divided by -1/2. So 1 divided by -1/2 is going to be a -2. Now I'm at pi. 1 divided by -1 is a -1. And then I'm at 4 pi over 3. 1 divided by -1/2 would be a -2. So there are my points. So when I graph this on my plane over here, I'm going to start by graphing those vertical asymptotes. We know there are odd integer multiples of pi over 2. So we're thinking pi over 2, 3 pi over 2, even negative pi over 2, and negative 3 pi over 2, and so on. Pi over 2, negative pi over 2. So let's start graphing some stuff. So 0, 1 here. Pi over 3, 2. Pi over 3 is a little bit bigger than pi over 4, 2. And I'm going to go back and hit this guy. So I'm at negative pi over 3, 2. So you can see what this guy's doing. It looks kind of like a U, right? And now I'm going down to this vertical asymptote here. Pi -1, 2 pi over 3, -2. Oh, 2 pi over 3, -2. 2 pi over 3 would be between pi over 2 and pi over 4. And then 4 pi over 3, -2. And we could always get some decimal approximations if we wanted to, just to figure out where it lives. So there's our iterations. Okay, so here's what's neat about this function. We know what the cosine function looks like, right? See if I can draw a cosine in here. The cosine function kind of weaves between all of these points. Cosine function had a point at 0, 1, pi over 2, 0, pi -1, and then negative pi over 2, 0, and negative pi -1. So here's your cosine function. That would keep on doing that pattern. So you can see how that cosine's kind of weaving in between that secant function. And we're going to see the same kind of thing when we talk about cosecant. So cosecant is equal to 1 over sine. That's going to help us figure out where our values are going to be. And that's the same thing as r over y by definition, right? Thinking back to all those definitions that we talked about the other. So to figure out domain, we need to know where the issues are. Okay, the issues are going to happen where y is 0, which is where the sine of theta is equal to 0. So if we think about our unit circle, where is that going to be equal to 0? Well, it's going to be equal to 0 with the y coordinate 0. So at 0 and at pi and at 2 pi and at 3 pi. 4 pi, 5 pi, 6 pi, and so on. In fact, it would also be negative pi, -2 pi, -3 pi, and so on. So it's really going to be integer multiples of pi, where k has to be an integer. So domain is going to be everything except k pi, where k is an integer. We call this theta again instead of x. So range-wise, this is going to look really similar to the last one, that secant function. We're going to hit y's that are less than or equal to -1, and then we're going to hit y's that's greater than or equal to +1. Period for this guy is 2 pi also. Vertical asymptotes are going to happen at every integer multiple of pi. And this symmetry is going to be an odd symmetry because it's based around this sine function. So now let's go in and let's find some of the values. So at -5 pi over 6, -5 pi over 6, we're going to be right here. So remember, it's going to be 1 over the sine, so 1 over the y. So 1 over -1/2 is going to be a -2. If I look at the next one, negative pi over 2, negative pi over 2, 1 divided by -1 is -1, negative pi over 6, 1 divided by -1/2 is a -2, and I can do the same thing with the other three. I'm going to get 2, 1, and then 2. So if we were to graph what this looks like, I'm going to start with asymptotes. So negative 5 pi over 6, negative 2, negative pi over 2, negative 1, pi over 6, negative 2. So something like this. And then pi over 6, 2, and then 1, and then back at 2. So just to show you, if we were to graph that sine function on top of it, sine had coordinates at 0, 0, pi over 2, 1. Work something like this. So you can see that sine function weaving between that blue cosecant function. And then if we were to look at that last one, cotangent, I'll just go through it really quickly. Cotangent is the same thing as 1 over the tangent, which is the same thing as cosine over sine. So same domain where theta's going to be, where sine of theta is going to be equal to 0 here. And we just talked about that. That happens at integer multiples of pi. The range is going to be all real numbers. Period is going to be pi, just like the tangent. Vertical asymptotes are going to happen at k pi. This also is going to be an odd function. Everything's even. I mean, everything's odd except for the two that's even. Cosine and secant. Cosine and secant are the only two that's even. If we were to look at our unit circle, I'm looking at negative 3 pi over 2 first. Sorry, negative 3 pi over 4. Negative 3 pi over 4 is going to have a, oops, sorry. Negative 3 pi over 4 is the same as 5 pi over 4, and that's going to have a cotangent value of 1. Negative pi over 2 is going to be at 0, then negative 1, and then 1, 0, negative 1, just coming off that unit circle. If I were to quickly graph everything, erase that. It's going to look really similar to that tangent function there. So there's our cotan, and I'll just kind of zoom in so you can compare with tangent. So you can see some differences between this guy and this guy, but a lot of similarities too. All right, so those are the 6 trig functions and domain, range, asymptotes, period, etc. for those.